Determine whether the given function represents exponential growth or decay. Explain your reasoning. On number 1, the b value is greater than 1, so it's going to be growth. For number 2, the b value, 0.2, is in between 0 and 1, so that's going to be decay. On number 3, 5 over 2 is equivalent to 2.5. So since 2.5 is greater than 1, it will be growth. Number 4, 25 is greater than 1, so it will be growth. On number 5, 1/6 is in between 0 and 1, so that would be decay. Number 6, growth, because 7.5 is greater than 1. So here's our formula for compound interest. A is the amount in the account after time t, P is the initial investment or the starting value, R is the rate written as a decimal, K is the number of compounding periods in the year, T is the time in years. Number 1, an investor deposits $1,000 in an account that promises an annual interest rate of 5%. So as a decimal, that's 0.05. You have to move your decimal point 2 places to the left when you're converting from a percentage to a decimal. And then it's compounded at the end of each year. How much will be in the account after 7 years? So I have my initial deposit of $1,000. And remember, I want to do after 7 years. So $1,000 for my p value. 1 plus 0.05. It's just compounded once, so k is going to be 1. And then my time is 7 years. So there's my initial equation, and I just have to type that all into a calculator. So since this is money, I'm going to round to 2 decimal places. So about $1,407.10. 2. At the start of the school year, Fairview High School deposits PTA dues in an account that offers an annual interest rate of 3.5%. So as a decimal, 0.035. I had to move my decimal point 2 places to the left. It's compounded at the end of each year. $2,500 to start with. How much will the school have at the start of the next school year? So basically you have 1 year. It's only been compounded the one time. So A of 1 equals my initial value, my principal of $2,500 times 1 plus my interest rate of 3.5% written as a decimal over 1 times 1 times 1. So type that into a calculator. And I'm actually getting an exact value on this one, so I'll put a regular equal sign instead of an approximately equal to sign. $2,587.50. Number 3, Kyle put $300 of his birthday money in the bank. The bank offers an annual interest rate of 4%, so that would be 0.04, because I have to move the decimal point 2 places to the left. It's compounded twice a year, so K is going to be equal to 2, and there was our initial value back there for the 300. How much money will you have after 3 years? So T is going to be 3. So I want to do A of 3 equals the initial value times 1 plus the rate as a decimal, 0.04, divided by K, which is the number of times it's compounded, so 2, raised to the 2 times 3, right? K to the T. So this one's a little bit more involved when you type it in the calculator. So I'm getting $337.85. And again, I'm rounding to 2 decimal places since we're talking about money. On number 4, an investing group has $50,000 to invest. So that's my initial amount. They put the money in an account that has an annual interest rate of 6%, so 0.06 written as a decimal. It's compounded monthly. So since there are 12 months in a year, K will equal 12. How much money will the group have at the end of 10 years? So T is 10. So A of 10 equals my initial value of 50,000 times 1 plus my rate, 0.06, written as a decimal, divided by K, which is the number of times it's compounded, raised up to the K times T. So 1 plus 0.06 divided by 12, and then raised up to the 12 times 10. So I'm getting 90969.84. So $90,969.84. Number 5, interest is compounded quarterly at Money Bank at an annual rate of 5.5%, so as a decimal, 0.055. It's compounded quarterly, so 4 quarters in a dollar. That means that K equals 4, so it gets compounded 4 times. And you have $7,200 to start, end of 6 years, so T would be 6. So A of 6 equals my starting value of $7,200 times 1 plus my rate is a decimal, so 0.055, divided by K, the number of times it's compounded per year, raised up to the K times T. So I'm getting about $9,992.48. I'm going to do a video too to do the rest of the worksheet, just because I know the large files take a long time to upload. So I'm going to stop this video here and do a second one in just a moment.